Good afternoon. All right, so how's everyone today?
Doing pretty good.
All right, so let's see. We've got Joran absent. Oh, well, hmm. Joran and Chloe. And anybody else? I think that's it. Uh, all right, so last yesterday we did most of 5-1. And I just want to tell you that uh, that uh, you guys probably didn't know it, but I actually had a visitor here, and I mean maybe you saw me talking or whatever, just to kind of see how the Talon system worked and to see how the classes worked and on the Talon, and she was very impressed with you guys. And you didn't like throw papers and stuff while I was teaching or anything. That was really cool. And no, but you guys were really engaged in the lesson yesterday, and she was really impressed. She was impressed with you. She was impressed with me, of course, um, and uh, and really kind of wowed at what we could do. And so I wanted to just to thank you guys, because you never know when someone's watching these or actually even viewing the recording. And I just wanted to tell you that I appreciated you guys being so focused yesterday. So I'm going to give you 5 points extra credit on your tests, just to say thank you. And you know, it's a week of Thanksgiving, and so I'm going to give you some thanks for working hard for me, and I really appreciate that. And who's so is Winslow playing with the lights or something over there? What's going on?
Our lights keep going in and out.
Are you? Is that all day?
It's been for about the past 2 hours.
For the past
Are
2 hours, yeah.
Are you kidding me? And they expect you guys to learn under that with the lights flickering? But oh well. Well, I appreciate you. So is my connection going in and out, or is it just your lights?
No, it's just lights.
Wow. Okay. All right. Well, anyway, I don't. I do appreciate you guys. So I just want to tell you that and thank you for that. Um, so what we want to do. Oh, so what? It's just weird to have the screen go black there. So what we're going to do today is we're going to finish 5-1, and then 5-2 is actually a pre-calculus lesson. There's almost no. It's just to kind of set up what we do. And so we're going to do that. And then what we're going to, now remember, we're not going to have class the rest of the week. Okay. So you guys don't have to come. You don't have to take any proctored quizzes or tests or anything like that. Now, what I've done with the trig classes is they're actually going to do, just to stay current, they're going to take some quizzes where it's going to be just sometime over the weekend. They're going to take a quiz, and there's not going to be any time limit, and they can take it on their own. Now, with you guys, where we're actually fairly caught up, we could theoretically take a quiz on 5-1 and maybe 5-2 if we get things done. But I'm going to totally leave that up to you. What we're going to do is at the end of class, we're going to vote. If you feel like you're ready to take a quiz on 5-1, then I will open it up from right after class through Sunday midnight, and you can just take it at your leisure. Okay? If you decide, you know what, I don't think I want to be ready, I don't want to do that, if you want some more time, that's okay too. And so we might not have any quizzes or anything to do. It's just, it might be nice to just take that off our plates so we don't have quite so much when we come back from Thanksgiving break. So I'll just leave it up to you though. We'll vote. So what we're going to do then is go to 5-1. I had asked you to do a couple of problems and just to see if we were okay. So the first one was practice 1D. So let's just go over the answer, and then if we need more help, then we can do that. So let's start with David. So practice 1D, if you could tell me what your answer was. And I don't know what's going on with my camera here. Can you guys see me okay?
Yeah.
Okay. All right. The cameras seem to be a little bit messed up. So, but as long as you can see the board, I mean, I just might not be at the board here. David, did you have an answer for 1D?
Is it 1.46075?
1.4. I got 1.9375. So let's look at this, okay? So this is the upper sum. So this is the table that you use. And so you should have, each width is 0.5. And then you look at the two y values for each side of the rectangle, and you take the upper, so it says the upper sum. So you take the 0.9375 for the first one, and then 1 for the second one, and then 1 again for the third one, and then 0.9375. And so that ends up giving you 1.9375. Okay. So do you see where you set that one up wrong?
I forgot one value.
Oh, okay. So, so just remember, since there's 4 rectangles, you got to have four values in here, 4 y values. And so I actually will count at the end to make sure that I've got them all. So that way, even if I use a 0 like we did on some of the other ones, I'll actually put in the 0 so that I know that that rectangle is accounted for. All right. All right. So any questions on that one? Okay. All right. Okay, then the next thing I'd asked you to do was practice 3. Okay. So the main difference here was we were going to find distance instead of displacement. So let's see. All right, Aiden, do you have an answer for practice 3?
I think 162 feet.
Okay, so so one of the things that's different on this one is that, you know how we had some of these values were negative. When we do the distance, you take the absolute values. And so there's no negatives that you put in. Okay. So you're going to have 16 numbers in here. And so you're using the lower estimate. So you're going from 0 to 8 seconds. And so in increments of 0.5. Okay. And
Yeah, I didn't see it was speed, sorry.
okay. Yeah, so when it asks for, so it's speed. So you multiply the speed by the change in time to get the distance. So it's the absolute value. So that's so all of the numbers here, probably if you still even had it in your calculator, you could just take away all of the negatives and chances are you'd probably have it right. So notice we're not using when you compare 160 to 144, because it's the lower estimate, you're using the 144. And then the last two, in 80 and 96, you use the 80, not the 96. So if you didn't get 480, just kind of verify. Oh, and that's the other thing that I was going to suggest you do when you're doing these for practice. You want to write this down. Write all the numbers down. I know you're going to put it in your calculator, but it's very helpful to just write this down before you put it in your calculator, because then if you mess up, you can kind of easily see, oh, I took the upper sum instead of the lower, or something like that. All right, any other questions on this one? Okay, then we have the average value of a linear function. The average value of function on A to B is, okay, so the V with a little bar over it, that's average. So this is the average value. And so it's the area of the function divided by the length of the interval. So the area is what we've been computing with the rectangles, okay? So this is, so we've been computing the area with rectangles. Oops, I don't want that. So you do that just like we've been doing. The difference is you divide by the length of the interval. So like if it's in the last problem, it was doing over 8 seconds. So then you divide by 8. That's the length of the entire interval. Okay. So here's the idea that if you want the average value of the function, okay, so you take, so here's this crazy function, okay, and then if you use the rectangles and you add up the areas and then divide by that, it's like smoothing it out and saying, okay, this is the average value right here. So that's the y equals c, that's the average value, okay? So let's say I want the average value of this function, y equals 3x from 0 to 2. All right? Now let's say I'm going to use 2 rectangles and the midpoint formula. Okay? So with 2 rectangles, I'm going to go from 0 to 1 and from 1 to 2. So each of those two rectangles has a width of 1. So I put a 1 there. All right. Now to get the y value. So when x is 0.5, the y value is 1.5. So I use that. When x is 1.5, the midpoint of the second base of the second one, then the y value is 4.5. So I add those up and I get 6. So if I was just doing what we did yesterday, the answer would be 6. But now I'm taking it one more step to get the average value. You take that answer 6 and divide it by the length of the interval, which is 2. So then 6 divided by 2 is 3. And so that's the average value of this function from 0 to 2. It's 3. And you might, see that geometrically, okay? But that's how we calculate it. Okay, so for practice 4, it says what is the average value of the function? We're going to do, wait. Okay, here we go. Estimate the average value of the function f of x equals cosine x from 0 to pi. I want you to use 4 subintervals and do the upper sum. Use the upper sum. So you might have to write that word upper on your paper. All right, so Hannah W., when you've got it, or if you need help, let me know.
I got pi fourths.
Okay. All right. So pi fourths is the area. Okay. But then you have to divide by pi because the interval is from 0 to pi. So that's the length of the interval. So you take pi fourths divided by pi, which is the same as times 1 over pi. And so the final answer is 1/4. Okay? All right, any questions on that? So using the upper sum, okay, so is there everybody okay on how we got pi fourths for the area? And then it's pi fourths divided by the interval, so you get 1/4. Okay? All right, now we're actually going to do this average value thing. It's going to come back 2 or 3 more times. Okay. So, anyway, any questions on that or anything else in 5.1? All right, so the question is so let's vote right now. We're going to go on to 5.2, and we may or may not finish 5.2, but for 5.1, do you want a quiz, like a kind of like a take-home quiz that you can take it, and no time limit for 5.1, or do you want to just wait till next week and take it a week from tomorrow?
We vote over the weekend.
Okay.
Yeah,
All
same.
right. Same there? Okay. All right. Well, let's just, I guess we should ask Skylar. What do you think, Skylar?
Maybe we could do it over the weekend.
Okay. All right. So let's do 5.1. And I think you actually, let's just see if we finish 5.2. I think you'll see it's a pretty easy section. So we may end up doing 5.2 if you vote as much. If you don't want it, then we won't do it. So I don't want you to feel too rushed on it. Okay, so 5.2 is, like I said, this is actually all from pre-calculus. It's only the very end where we make any kind of connection to calculus here. So this is on sigma notation. And then limits of finite sums is where we make it to calculus. But most of it is about the sigma notation, finite sums and sigma notation. So the sigma notation enables us to write a sum with many terms in compact form. So if we're going to add up 10 things, or like we've just been doing with all those rectangles, we can use the sigma notation to make it more compact. Okay? And so whenever we have a lot of things that we're adding up, the sigma is the Greek S, and it actually means to sum it up, to add them up. Okay? So if we're adding up a bunch of things, we can use this sigma notation. So the summation symbol, the Greek letter sigma, that's the thing, it looks like an E, but it's actually an S. And then the number here, where it says K equals 1 to N, K is what's called the index. And so here the index K starts at K equals 1 and goes to N. Now, if you're familiar with any kind of computer programming, and I know some of you are because of like robotics and whatever, it's kind of like it's kind of like doing a loop in computer programming, where you're telling it how many times to do the loop. And then here, a sub k, that's the formula. So whatever math formula you want to add each time. Okay. So if we want to find the value for each, we're just going to kind of work through a couple of these practice problems together, and then I'll have you do a couple of them. So you just start with k equals 1, and it goes to 6. So in the formula here is just k. So when k is 1, we just write down 1. And then k goes up by 1 each time. So then it goes 2, and then 3, and then 4, and then 5, and then 6. And so then the last thing is the summation symbol means add them all up. And so then our answer is 21. Okay. All right, now this right here where we have negative 1 to the k, that's what I call an alternator. Because what that does is it alternates from positive to negative each time. So here when k is 1, I have negative 1 to the first, which is negative 1, times 1, so that's negative 1. Plus, okay, then when k is 2, I have negative 1 squared times 2. Plus, negative 1 to, so now k is 3. So negative 1 to the third times 3. And then negative 1 to the fourth times 4. And then you simplify it each time. So you just start plugging in 1 for k, 2 for k, 3 for k, 4 for k, and then the sigma means add it all up. So this would be negative 1. 1 times 2 is 2. Negative 1 times 3 is negative 3. Positive 1 times 4 is 4. And so that gives you 6 minus 4 is 2. All right. So let's see if you can do C and D. All right, Rhett, when you have C.
3.5.
3.5. Okay. So, yeah, so when you plug in 1, and then you plug in 2, so you get 2 over 1 plus 3 over 2, which is 7 halves or 3.5. Okay. Now, while this is pretty easy, you can actually, your calculator will do these, the sigma notation. So let me just show you how to put that in. Okay. So if you go to math and then arrow up to 0 or down to 0, where it says summation, and then you press enter, and so then it has you put in your index. So you can use any variable you want. I usually use X because then that's just one keystroke. So X equals, and then you do 1 to 2, and then you type in the formula in the middle. So because I used X, it's X plus 1 divided by X. And then I got the same answer that Rhett did. So 7/2 or 3.5. Now, because sometimes you use variables and you can't really put it in your calculator, you want to make sure that you understand how the summations work. But I'm showing you how to do it in the calculator if it gets too complicated or if you want to check your work. All right, so Rhett, how about D?
17 and a third.
17 1/3. That's right. Now, remember, let's say that all the answers are fractions. Remember you can use the answer as a fraction key to convert to a fraction if you need to. Okay? Any questions on either of those? All right. Using different index starting values. The lower limit of a summation does not have to be k. It can be any variable. So a lot of times you'll see I, j, k, or like when I put it in the calculator, I use x. So now we're trying to write this expression in sigma notation. All right, so what you do, first you count up how many numbers you have. So there's 4 numbers. So you could let k or x go from 1 to 4, for example. All right, now can you see a pattern here of what these numbers are? And frankly, this is where the more practice you do on these from the book, the better you're going to be. Because it does take some practice, some trial and error to get to see the patterns. Anyone see a pattern there in the numbers?
It's a multiple of 3.
Okay, so a multiple of 3. So how could I write that as a formula? So every time I'm multiplying by 3 again.
X times 3.
Okay, except see, we wouldn't, if it was x times 3, then we'd have like 1 times 3, so 3, but then it would be 2 times 3 is 6, 3 times 3 is 9, and so on. So that's not it. This is actually, but what you said is the most common thing that students say, because that's what I put it down there. But that's not going to work. So what you have to do is kind of do a little trial and error. See, the k goes from 1 to 4. That's true because you have 4 numbers. But it's not 3 times k, because it would be 3, and then when k is 2, it would be 6, and then 9, and then 12. So how do I get these numbers?
Would it have to be 3 to the k or 3 to the x?
Yes. It's exponential. Okay. So to get those numbers, it's going to be 3 to the k. So now when I have k is 1, I get 3, and then when k is 2, 9, and then 27, then 81. So that would be, so good job, Hannah. That's exactly what it is. And so that's what I'm saying is that sometimes, you try these and look it up in the back of the book or something, and you're like, oh yeah, it's 3 to the k. And so you start kind of learning how to play with the patterns a little bit. All right. So let's go on to the algebra rules for finite sums. Okay. So basically, if you want, you could either write down, if you want to just write down the words, basically, if you have two summations, you can add them, the formulas together, or add them separately. Or the difference rule says you can subtract them or subtract them separately, work them separately. If you have a constant, you can pull the constant out front. Or if you just have a constant as your formula, then that's going to end up being the constant added to itself n times, or n times c. The reason why I say if you could write down one or the other, but basically you kind of just need a reminder. But these formulas all work the way that you would guess. I mean, if I didn't tell you these and just had you work them through, you would get them right anyway, because it's pretty intuitive. All right, anybody need any more time on this one? Okay, so now what I'd like you to do says use the finite sum algebra rules to find the value of the sums. Okay, so you can do it by hand. You can put them in your calculator. You can do both and just sort of check to make sure you're getting them right. Whatever you feel like that you need to do on those, and then we'll check our answers in just a couple of minutes. All right, so Denon, when you have the first one.
60.
All right. Good job. Any questions on that? All right, Aiden, when you've got the second one.
Is it -10?
Yep. So the way the formulas work, so like you could do plug in 1, 2, 3, and 4, -1, -2, -3, or you could pull the negative out front and just do 1 + 2 + 3 + 4, and then take the negative of it. So -10 is correct. All right, so Dylan, when you've got the third one.
-10.
Okay, so also -10. So this person just plugged in directly, or you could do 1 + 2 + 3 + 4 minus 5 times 4. That might be quicker. All right, so Aiden, when you've got the last one here.
137 over 60.
Great job. Any questions on that one? All right. Okay, now there's different patterns that we use summations for. So like this they have the sum of the first in squares, the sum of the first in cubes. But the one that we're going to use is the sum of the first in integers. So it's the sum of k equals 1 to n of k. And so it just simplifies to n times n plus 1 divided by 2. So if you were going to say sum up the first 20 integers, then it'd be 20 times 21 over 2. And so, man, that's way quicker than even doing it in the calculator. Okay? So see if you can use this formula right here to find the sum of the first 1,000 integers. All right. Hannah W.
I got 500,500.
Very good. So it's 1,000 times 1,001 divided by 2. Okay. All right. Any questions on that one? All right. Finite sum approximations get more accurate as the number increases or they get smaller. So actually, so is the number, I'm actually going to put the number of rectangles. So as the number of rectangles increases or as the rectangles get smaller. So if their width is smaller, it'll be more accurate that way too. All right, so what we're going to do then is use the idea of a sum. And we're really only going to do this. We're only going to really do this one time. Okay. So the idea is that if we have the limit as the norm approaches 0. Okay, so let's talk about the norm. So normally when I've done rectangles with you is that all of the widths were the same, but they don't have to be. So the largest width is what we call the norm. So like here, this width is 0.5, 0.1, 0.2, 0.2. So the norm would be 0.5. So it's the largest of the widths. And so then what you do is you say, the limit as the norm approaches 0 of the sum as n goes from 1 to infinity. And then you have your x to the n, which is like the width of each rectangle. And then you put the function, whatever the function is right there. Okay? So So it says find the limiting value of a lower sum approximations to the area of region R below the graph of y equals 1 minus x squared and above the interval 0 to 1 on the x-axis using equal width rectangles whose width approaches 0 and whose number approaches infinity. All right. So what all this is saying is to write this as a summation. That's really all it means. Okay? So we start off all of them as the limit as the norm of p approaches 0, and then n goes from 1 to infinity, and then we've got this on this interval from 0 to 1. So this part in red, all of them are like that. Okay? So now what else goes into the limit is the function. So what up here is the function?
One minus x squared.
So 1 minus x squared, and then we put the delta x or the dx or whatever. That's the width of the partition. And that's really it. So what changes? The purple part changes from problem to problem. The function just goes here, and then whatever the interval is goes there. Okay? All right, let's, so rectangles approximate the region between any two functions. So this is sort of a setup to what we're going to do in the next section. Okay? So between two functions. But then I wanted to ask more questions about the norm. So let's look at practice 6. So here's the set. So this set goes from 0 to 3. So imagine these are like the widths of your rectangles on the x-axis. So how many subintervals are there?
6.
Okay, there's 6 numbers, but see, the first interval would go from 0 to 0.6. And
So
then from
5.
0.6 to, yeah, so there'd only be 5 subintervals. So it's like the fence post thing. Okay? All right, so what are they? Well, I just said the first one. So it goes from 0 to 0.6. And then from 0.6 to 1.5. So what would the next interval be, subinterval be? So it would be from 1.5 to
2.1.
2.1 to 2.6, 2.6 to 3. So what is the norm? Which of those is the biggest?
3.
3? No,
2.6
3
to
is the
3.
distance of the whole thing. The norm is the biggest of these subintervals.
0.9 between 0.6 and 1.5.
That's it. 0.9 is the norm. It's the biggest of the subintervals. Okay? All right. I think let's not do the quiz. I mean, unless you guys do want to do the quiz on 5.2, we're out of time.